Oh, thank you everyone for being here. Thanks to the organizers. I'm super excited to be in such a wonderful session. Thanks, Will, for sharing. I'm here today to talk about some work around a package called Vega Widget, which we use to compose and render interactive Vega Light charts. And what I'm going to touch on in this presentation is how we can use Vega Light in the browser, how we can render Vega Light specifications as HTML widgets, and then how we can compose Vega Light specifications. But I want to start out by emphasizing really the group nature of this project. So I'm Ian. I work at Schneider Electric. I'm super grateful for the support they've lent to this project. And I have a wonderful group of collaborators, Alicia Shep from Livongo, Stuart Lee from Monash University, Haley Jepson, who is in the room somewhere here, who's at Iowa State and also a colleague of mine at Schneider. Wenyu Yang, who's a Google Summer of Code student. We'll see a project that we're working on with him a little bit later. And we're very grateful for the continued support and mentorship of Heike Hoffman at Iowa State. So the question comes up, what is Vega Widget? At this point, it's a package on CRAN that you can use to render Vega Light specs. But as I put this talk together, I saw that it was becoming more and more a talk about the organization itself, the group of people we see here. At its root, Vega Light is interactive grammar of graphics rendered in the browser. It's built on Vega, which you may remember from the Hadley Wickham's GIGAVEGA project. Vega Light is more concise, but less expressive. And this is developed by Jeff Hare's lab, the Interactive Data Lab at the University of Washington. And it's also the foundation for the Vega Light R package that you may have seen by Bob Rudis and coworkers. So here's what it is. I have a couple of examples. This is linked brushing. This is the famous iris data set where we see on the right, we have petal width by petal length. On the left, we have sepal width by sepal length. We're coloring here by species. But when we compose these together in Vega Light and add some selections, we can get linked brushing. So I can make a selection on one side, they're highlighted in the other, and vice versa. Another example is overview and detail. Let's imagine this is maybe some sort of stock price. I think, in fact, it may be a stock price. We have two representations of the data, time being on the x-axis, price on the y-axis. But what you'll see is we can select on the bottom visualization, and this will drive the scales for the top visualization. So we can use this to zoom in, pan and scan, and then deselect to zoom back out again. So these are some of the interactions that are baked into Vega Light, and this is all in JavaScript. And I talked a little bit about Vega Light being an interactive grammar of graphics, and I'm sure many of us are already familiar with grammar of graphics. So I thought I would take a little detour through grammar of graphics as food. I'm not sure how many folks would have seen the Netflix series by Samin Nosrat, Salt, Fat, Acid, Heat. I got the book, and it really spoke to me in the sense that for the first time that I understood that you could decompose a meal into elements that you should balance. And just to acknowledge the wonderful artwork by Wendy McNaughton as well. And it spoke to me in a way that the Hadley's ggplot2 book spoke to me in the sense of how you can compose an effective graphic, or here are the tools that you can use. So if we look at the same graphic again, this is the petal part of the Scatterplot that we have in ggplot2. We have the familiar elements of data, stat, AES, aesthetics, and geom. When we go to Vega Light, we have the same things, but instead we're working with data, transform, encoding, and mark. And we see what the same graph looks like in Vega Light. So this is where we get into a little bit of the ugliness, but spoiler, it gets better. This is a JSON specification that we build to, that will then get rendered into this chart. And again, we can see we have our data and not nearly enough room to show what the data looks like. That we have a mark, which is point. We have encoding to x-axis, y-axis, and to color. We have to make a little trick here if we have a dot in the title, but that maybe makes us a little more verbose than I would like. But the thing is that we have to work with this, at least initially, with this somewhat unfriendly JSON representation. So I'm going to tell a bit of a story here of how we start. The rest of the presentation is where we start with Vega Light, and we have a chart that somebody is looking at. And this is done in HTML and JavaScript in your browser. And this starts out with this JSON specification that I just showed you. And there's a rendering process, and this will be done by Vegawidget, which handles translating from the JSON spec to the chart. And then the really good news is that if you have an idea for a chart, the folks in the Vegawidget organization are developing packages that will make it easier for you to compose these JSON specifications. So to start out with what the Vegawidget package does, this is by myself, Alicia, and Stuart. It's an HTML widget package. It renders the Vega Light specifications, and it provides us with some access to interactivity. And just to stress that this is intended as a low-level package, we'll use Vegawidget to render, but we'll use other packages to compose. And if you're using Vegawidget, at least we have a list to use here, but it's not that much more friendly than the JSON that we just saw. But one thing that it does provide to us is interactivity. Vega, through its JavaScript API, allows us to swap out data. It allows us to work with signals, which we could think of in the Shiny world as reactive variables, and events. And Vegawidget has some functions that make it a little bit easier for you to build this into your Shiny app. And I'm going to show an app here by Stuart Lee. This is it should be a reasonably familiar data set of Gapminder. And what's being shown here is for the year 1952, GDP per capita on the x-axis, life expectancy on the y-axis. We're coloring by continent and sizing by population. And I'll just sort of walk through this here. That we'll start in 1952, and then what the Shiny app will do, first to show that we have some nice tooltips here as well. But Shiny, when we update the year, Shiny is swapping in and out new data sets filtering according to the year. And it's really neat because it's only the data that's changing and we don't have to rebuild the graph. Vega knows that it's just the data changing and it knows the right thing to do. Next package I want to talk about is Altair, and I'm afraid this slide is just a little bit out of date. Submitted to CRAN a couple of weeks ago, and in an amazing bit of timing, I got the notification over lunch that this is now on CRAN. This is a package Altair written with Haley and Alicia that wraps the Python Altair package through Reticulate. It's the package by Jake Vanderplas and Brian Granger. A neat thing is that it covers the entire Vega Light API using a concise syntax, and we have the website for the Python Altair package here. The one thing I want to emphasize is Haley spent a lot of time reproducing the entire Altair gallery, so a way to demonstrate, if only to ourselves, that anything that you can do in Python Altair, you can also do in R Altair. So here the syntax gets a little bit friendlier. We were able to specify and that we want to use iris, we're using a mark, that we have some wrapping functions to do the encodings, and property function to say how big we want our visualization. And again, we get our same chart. This next package is, to me, really exciting. that this is by VL Builder by Alicia Shep, and that the API here is heavily inspired by the Vega Light package that I was talking about earlier. Alicia was one of the, is one of the contributors to the Vega Light package, but now that we have the Vega Widget available, that she's building a new package, and she's able to build the entire Vega Light API right from the Vega Light schema. And it makes, on her side, updating the package and the functions much more automatic. If Vega Light changes something, she can make an update automatically. And this is the same approach that the Altair Python folks use, and there's a Vega Light API JavaScript package. But the super exciting thing for us is that we can now compose Vega Light specs using the pipe. So again, the same visualization, we instantiate a chart, we add data, we say we want a point mark, and then we have functions that say encode in X, encode in Y, encode in color. So this is, I think, starting to get rather friendly. Finally, about these composition packages, I want to talk about a project Haley and I are very excited about. We have a Google Summer of Code student, Wenyu Yang, and our ambition is to translate from ggplot2 to Vega Light. And obviously, this is inspired by Plotly and Carson Siebert. Now, as I'm sure you know, ggplot2 is declarative, so is Vega Light. And what this means is we want to specify the what, not the how, of building a visualization. So the ambition of GIGAVEGA is to translate only the declarations. And from Schneider Electric's point of view, this is interesting because now we can build something, a visualization in ggplot, and then have a specification, and we can start to deploy that to a customer. And that we can make sure that our intentions as data scientists about what should be in the visualization, that there are fewer opportunities for things to get lost in translation. So here's how we do things in GIGAVEGA. I want to emphasize this is still very experimental, and I'm showing pretty much the entire set of capabilities you're seeing right here. But we can make a ggplot and then call the function as Vega spec, and it will render as a Vega Light visualization. And the neat thing here is now we can mix and match. So when I was working on this presentation with Haley, she said, I really would prefer those symbols to be filled in. And that got us thinking that, well, why don't we just mix and match? We'll bring in VL Builder. We'll then pipe our Vega spec to a VL Builder function that will tell us that we want to encode the fill according to the species, and voila, we have now filled symbols. So this is an exciting thing we can do to mix and match, and we can even add interactivity this way. And I want to emphasize that this is very experimental. So this function that operates on a layer is, we have something up in our Studio Cloud, but want to show that we can add an encoding for opacity, that we can add a selection, and then we can say if we're selected, we want the opacity to be 1. If we're not selected, we want the opacity to be 0.3. Do the same with the sepal, concatenate our specs, and we get the demo that we saw at the top. So to summarize, we have 3 steps here. That Vega Light is for the end, is what the end user sees, an interactive grammar of graphics, JavaScript rendered in the browser. Vega Widget renders Vega Light specifications and provides you some interactive access to Vega Light charts. And we have a series of packages that help you compose Vega Light specifications: Altair, VL Builder, and GIGAVEGA. Again, here's the team. I'm over the moon to be working with these folks, and to I'll leave up this summary slide and give the floor back over to Will in case there's any questions. And thank you very much.
Okay, great. Any questions? Am I missing any questions? Okay, I have a question. So what is the output format of these plots? How easy is it to say, is it going to give you an HTML page you can just take and copy or put it in an iframe in the browser if you want? Or is this mainly something that's meant for Shiny and R Markdown?
Shiny and R Markdown if you're in the R ecosystem.
Yeah.
But the neat thing about this specification is that if anybody else is using Vega Lite or has a Vega Lite viewer or renderer, you can take this specification, hand it over to them, and then they're able to see what you saw.
Great. Okay. Yep.
Here, which framework are you using to make the presentation?
Pardon me?
Which framework are you using to make the presentation slides?
Oh, PowerPoint.
Is it possible? Yeah, I'm here. Is it possible to use in this Vega Lite external data sources to draw plots?
Yes. I don't have a slide on it, and I'm not going to attempt to do anything with this keyboard. But you, instead of, here, let me back up a bit. Actually, I'm not going to mess with this at all. That you can, instead of providing the raw data, you can provide a URL. And as long as that URL serves up something that's in the nice JSON data format, Vega Lite will treat it equally.
Jim, just a question here.
Yep.
Hello, I'm here. The question I have is it possible to, because you have this crosstalk between two plots, right? You make the brushing and then you get it highlight in a different plot. Is this crosstalk also possible with, let's say, other JavaScript components like tables, DT table, etc.?
In theory, yes. I haven't figured out how to do it yet, but Vega exposes these things that they call signals. And so in theory, there should be a way to hook up the signal that's going to and from a Vega visualization to another component, but then it becomes your responsibility to define that interaction. And Shiny makes a lot of that easier, but if you know JavaScript, all that is open to you. But I'm not an expert on that part myself.
All right. Thank you very much, Ian.